How's it going, guys, and welcome to another Java video. So in this video we're going to cover the difference between depth first search and breadth first search, and these are two great searching algorithms when you have a graph and you want to search through every single vertex in the graph. So just some quick terminology. A vertex is this circle right here with a number inside of it, and every single line connected to it is an edge. And adjacent means directly beside. So the two vertices adjacent to 1 is 2 and 5. So let's begin with depth first search. So with depth first search, what we do is we start at the very beginning, or a source vertex. And just for simplicity, I denoted this with 1, 2, 3, 4, 5, 6, 7. They could have any random numbers. I just kept them nice and clean. So we start off with, let's say, 1. And now we visit every vertex, and then we close off that vertex and move on to another vertex. So we start at 1 and we go to 2. So we close off 1 and visit 2. So what values or what vertices are connected to 2? We have 3 and 4. Are we going to visit both? No. We're going to visit 1, and then we continue visiting all its nodes. So we go to 3, and we see that there's no vertex connected to it. So we backtrack and we go to 2, and then from 2 we notice that there's 4. We haven't gone there yet, so we're going to visit 4. 4 doesn't have anything attached to it, so we go back to 2, back to 1, and then we visit 5. So 5 has 6 and 7. Do we visit both? No. We visit 1 at a time. So we're going to visit 6, and we see that 6 has nothing attached to it. So we're going to go back to 5, and then from 5 we visit 7. So we see that 7 has nothing connected to it, so we're done that. So we're going to go back to 5, and we're going back to the source. So this is sort of inefficient because we have backtracking, which means that once we're done visiting a node, or once we're done visiting a vertex, we go back to a previous vertex that we've already visited. So this can be kind of expensive. So with a depth first search, we have a stack. And if you've seen my data structures and algorithms videos, I talk about stacks and queues and how we can implement them. So with a stack, this has a LIFO, which is the last in, first out. So the very last item inside of the stack is the first one that's going to get out. So we visited 1, so we're going to put 1 right here. And then we go to 2, and then we add 2 to our stack. And then we went to 3. So once we went to 3, we saw that there's nothing connected to it, so we go back to 2, and then we add 4. And then we now backtrack all the way back to the source, and then we go to 5. So we add 5. And then we went to 6. And then we went back, and then we visited 7. So just for simplicity, I have 1, 2, 3, 4, 5, 6, 7. We could have done this in many different ways. We could have went to 1, and then went to 5, and then 7, and then backtrack, and then went to 6, and then back, and then 2, 4, 2 again, and then 3. There's a lot of different possibilities. This is just one way to have done this. So now let's cover a breadth first search. So I'm going to change the color. So in a breadth first search, we have a queue, and a queue is a FIFO, which is a first in, first out. So, which intuitively makes sense because, let's say, for example, we're waiting for the movies. The first person in line is going to be the first person to get out, or the first person to enter. So, again, we start off at our source. And now, with a breadth first search, we add the 1, and we add every single adjacent vertex attached. So we have 2 and 5. So we now suspend 1 because we've already been there, and we go to 2. And we add every single adjacent vertex attached to 2. So we have 3 and 4. So we're going to add 3 and 4 to our queue. So 2 is complete. We visited 2, so now we suspend that and we go to 5. What vertices are connected to 5? Well, we have 6 and 7. So we add 6 and, oh man, what happened there? So we add 6 and 7. So as you can see, every single vertex was visited. So the benefit of this is that there's no backtracking. So we don't go back and forth to a vertex that we've already visited. Here, in depth first search, we have backtracking. So it's sort of inefficient. So that's pretty much the main differences between a depth first search and a breadth first search. So why is this useful? So let's say we're at a workplace and our source is the highest level in the hierarchy, and that, let's say for example, is the CEO. And the CEO has 2 managers attached to it. And then the managers have 2 employees attached to them. These are 2 very good types of search algorithms that you must master for your technical coding interviews, and they can be kind of confusing because you don't really know which one's which and what's going on and what's the difference between them. So that's why I made this video, because I haven't really seen anything that really explains it simply. So this is like possibly the simplest way that I can explain the difference between depth first search and breadth first search. So I really hope this video helped. If it did, please leave a like and please remember to share and subscribe, and I'll see you in the next video. Thank you so much for watching.